Magnesium is a metal. Describe the structure and bonding of metals, including a label diagram in your answer. So let's bring that in. This is how a metal is. So regular arrangement of positive ions with electrons around it, right? So how do we explain this? Let's do that now. Now I'm going to answer in points, but you can turn that into a sentence. So let's try that. So it is a lattice of positive ions held together by a sea of electrons. This is a keyword right there. You should always try to use this description. Sea of electrons. Sometimes people will call it a cloud of electrons. Sea of electrons. Either is fine. Moving on to the second part. Here we go. Let's begin. Magnesium reacts with oxygen to form an ionic compound, magnesium oxide. Complete the dot and cross for this diagram. So magnesium, well, has 12 electrons looking at the periodic table, right? And it'll lose 2 electrons because it's in group 2. So it'll have how many left? Well, 10 left, 2 of which are already drawn. So let's try drawing the rest. So that's 1, that's 2, 3, 4, 5, 6, 7, 8. Makes sense because it lost the 2 outer electrons in its shell. So the entire shell is gone, and the hint is that they haven't drawn the third shell. What's the charge on magnesium? Well, that's straightforward. 2 plus. 2 plus and not plus 2. Make sure you're getting that right. Whenever you're quoting charges, it's 2 plus. For oxygen, it has 8 electrons, and to get an outer octet, it'll actually gain 2 electrons, receiving a charge of 2 minus, right? And let's put those electrons down. Well, that's 1 and 2, 7 and 8. There we go. Easy peasy. All right, let's bring our attention to the next question. Here we go. Magnesium oxide melts at a very high temperature. We can see pretty high, which is interesting because you should know magnesium oxide is used to line the inside of kilns and furnaces because it has a very high melting point. Why does magnesium oxide have a very high melting point? Well, knowing that it has it is an ionic compound and the ions are held together by very strong ionic bonds, right? So you can say strong forces are holding the ions together. The ions, sorry. Yeah, this won't do. The ions together. Explain why molten magnesium oxide can conduct electricity. Well, because when in molten form, you should write, the ions are free to move, essentially. That's your scoring mark. And allows the conduction of electricity. Predict the physical state of fluorine at room temperature and pressure. Well, fluorine, it's common knowledge at this point that it is a gas, a gaseous compound. To our next bit. Alright, fluorine exists as a diand atomic molecule, right? And show the arrangement of show the electron arrangement in the molecule of fluorine. Well, fluorine is in group 7 and it only wants to fluorine is in group 7, has 7 outer electrons, so only wants to make one bond to gain one extra electron, and it can do that with the other fluorine. And similarly, this fluorine is also happy because it's just gained each of them are sharing 1 to gain 1, so both should have 8 technically. So let's confirm that. Fluorine on the left will be blue dots, and fluorine on the right will be these X's. We can see there are 7 of these crosses, 7 of these dots, but each orbit of the element has 8 each. That makes fluorine very happy. Okay, next one if we can. Write the chemical equation of the reaction between sodium and fluorine. Well, we're not doing that, so ignore that. That's not related to bonding. Right? Explain why chlorine does not react with aqueous sodium fluoride. Well, we don't need to know this either, so then we can move on. Tetrafluoromethane and lead fluoride are group 4 elements. Some properties of these compounds are shown in the table. So that tetrafluoromethane and lead fluoride. There's no formula for lead fluoride, which is interesting. I think they'll ask us that. So no problem there. There we go. What is the formula of lead fluoride? Well, lead is, if you check the periodic table, is going to be Pb. The Roman numeral over here is telling you the charge on lead. So it's going to be positive because it's a metal, and 2, right? Fluorine has a charge of 1. Negative 1 because it's a non-metal. Well, you need 2 of these to balance it out. So the charge will be, or the formula will be PbF2. What is the type of bonding present between the atoms of tetrafluoromethane? Well, I would assume, well, it has a very low melting and boiling point. Out of the 4 types of bonding, which has very weak or like a very low melting point? Well, it's simple covalent molecules. So what type of bonding is present between the atoms? Well, it's covalent bonds. Because for simple covalent structures, the bonding type is covalent. So covalent bonds. They're not asking about the structure, so we won't say they're covalent compounds. It's a covalent bond. And it's not van der Waals because it's between atoms. Van der Waals is actually between the molecules. The next question is asking what type of structure does lead fluoride have? Well, it has very high melting and boiling point. So it could be macro, metallic even, or ionic. But it's not a good conductor of electricity, so metallic's out, but it's a good conductor as a solvent. Oh, sorry, not as a solvent, when it's molten. So free moving ions, right? What has free moving ions when it's molten? Well, ionic compounds do. All right, so it is an ionic, what type of structure? It is an ionic structure. Ionic structure. This is the more challenging question. It's easy to understand, but how do we answer it? Well, explain in terms of attractive forces between particles why an ionic compound has a much more higher melting point than a simple covalent structure. In your answer, refer to the type of attractive forces, and that's the best way to do it. They're actually giving you how to talk about it. no matter, even if this wasn't given to you, you should talk about it like this. So first, we talk about how they're different. Well, they're different because lead fluoride, PbF2, or you can just write down lead 2 fluoride, is an ionic structure and is held together by strong ionic bonds. That's 2 words, which are has strong ionic bonds holding it together. Whereas tetrafluoromethane, CF4, has weak, not covalent, right? Weak van der Waals forces of attraction. So how do you make your third statement? Well, the ionic compounds, or actually let's talk about ionic compounds. Large amounts of, or actually we should say high energy is required to overcome the strong, you don't have to say strong, I'm just trying to make a case. The strong ionic forces or ionic bonds compared to I want to change the color, compared to the small amounts of energy that can overcome the weak attractive forces in CF4. All right, draw the dot and cross structure to show the electrons arrangements in the molecules of methanol. Show outer electrons only. So what's interesting about this is you have carbon given to you. Carbon is in group 4, can only make 4 bonds. This is a slightly different way of doing it because we can't keep track of all electrons. So carbon wants to make 4 electrons. Hydrogen wants to make 1 bond only, and oxygen can make up to 2 bonds, right? So let's try to figure it out. Carbon, that's 1, 2, 3, 4, right? So each of these hydrogens are happy because they've made 1 bond each, right? Now oxygen wants to make 2 bonds. It's already made 1. It can make another one like that. So yeah, so let's fill these up with electrons. Right? And I think over here as well. So actually it's kind of confusing. So let's make this a circle instead of a dot, and we have a circle with an X. The X's are hydrogens. So we're only left with oxygen, which doesn't have enough electrons. So I'm drawing those. Now we can see each of these are bonded to correctly, right? So hydrogen, this hydrogen has only one electron, carbons sharing one with it. Same over here, same over here. Oxygen has 6 in total, so that's 1, 2, 3, 4, 5, and 6, right? And yeah, looks pretty good. So this is a good way of trying to figure it out. Now, one thing, this sort of question won't show up in your test or in early assessments. This is actually an organic molecule. It's called methanol, right? I'll write the name down. Methanol. So we'll be a lot more comfortable much later to do this, but this is good practice. If you can do it, great, but don't expect this quality of question to show up in your test or exam this year for grade 10. All right, so we have a table with melting point, boiling point, electrical conductivity, and electrical conductivity as a liquid when it's molten, right? So I guess we can just quickly figure out which each of these type of substances these are. So D does not conduct electricity as a solid, so it's not a metal, and nor as a when it's molten. And the temperature is very high, so it's not simple covalent, it's not metal, it's not ionic. So we're left with that is a giant covalent structure. Giant covalent, kind of like diamond. All right, so E, relatively high melting boiling point, simple covalent is out. Doesn't conduct, but conducts. Oh, ionic, has to be ionic. Ionic. Then we have F, very low melting and boiling point, that it has to be simple covalent. G, high, good conductor, has to be a metal. Okay, low, non-conductor. We have our simple covalent back. And last one, pretty low. That's simple covalent as well. Right? Okay, which of the substance is a liquid at room temperature? So to be a liquid, the melting point, the boiling point has to be higher than 25 and the melting point has to be lower than 25. Right? I mean, that should make sense. For I, the boiling point is negative 196. So at room temperature, it's going to be a gas. Right? Now, over here, the melting point is 114, meaning that to melt it, you have to raise the temperature to 114 in order to melt it. And out of all of them, it's only F, because it's only going to be a simple covalent, right? Very unlikely it's going to be a metal unless it's mercury. So out of these three, it's only this where 25 lies between these two values, right? So the only possible answer for us right now is F. Moving on. Which substance is a gas at 25 degrees? Well, out of all of them, it looks like that's going to be a gas because it boils at negative 196 after that. So this is going to be solid, a liquid, and a gas. So our best option right now is I will be a gas. Well, not me, but which three substances contain simple molecules? Well, as we already talked about this, it's pretty cool that this question showed up. It's F, G, and I. All right, I don't know why I said G. It's actually, the other one is H, right? Moving on to the next part, well, let's take a look at D now. Now, which substance could be a metal? Give your reason. Well, a metal will be a conductor of electricity as a solid. So the substance is, well, G. And because it conducts electricity as a solid. That's important to say because ionic compounds will conduct electricity as liquids. Which substance has a macromolecular structure? Give 2 reasons for your answer. So the best bet for us was that it is D, because it has very high melting point, but so could high ionic compounds. They're asking for 2. So high melting point and boiling point, right? Melting, boiling, melting point. And the other one that's important is that it doesn't conduct electricity in any state. Doesn't conduct electricity as a solid or liquid. All right, last but not the least, we have F. Which substance is an ionic solid? Give 2 reasons for it, or just give a reason for it, right? That's straightforward. Well, the answer is E. And why is that the answer? Well, because E can only conduct as a liquid. That's the best. That's only for ionic compounds, right? So conducts electricity. Conducts electricity as a liquid. Liquid. Awesome. For question number 5, we'll ignore the first bits. We're only going to focus on the dot and cross diagram. So phosphorus is in group, what do you call it? Group 5. So let's draw that, crosses for that, right? And chlorine is in group 7. So just making 1 each. Now chlorine, you should know at this point that can only make 1 bond, because sharing 1 gives it 1, and it has 8 outer electrons. So all of these chlorines are happy. So phosphorus won't bond anymore, right? How many electrons does phosphorus have? Well, it's in group 5, so it should have 5. You've already drawn 3. So that's 5. So looking at phosphorus, it looks pretty happy because it has 8 electrons in its orbital. And chlorine, we already know, is happy. And we can draw the rest of them. So let's do that. And there you go, PCl3. Let's move on. Melting point of magnesium fluoride and carbonyl fluoride is shown. So magnesium fluoride is 1200, approximately 1250, 1263. Carbonyl fluoride, well, it's very low. That's telling you something about its structure. But it's a metal with a non-metal, that's also telling you about its structure. Well, magnesium fluoride will be, for all intents and purposes, and also really, ionic. And for carbonyl fluoride, it'll be simple covalent, a simple covalent molecule, right? So what's responsible for the melting point for this? The ionic bonds, which are very hard to overcome, where a simple covalent has weak van der Waals forces, which are easily overcome. So let's put that into words. Explain, using your knowledge of structure and bonding, why carbonyl fluoride has a low melting point. So let's give that a crack if we can. forces. Carbonyl fluoride has weak van der Waals forces that hold it together, as it is a simple covalent structure. That's why it has weak van der Waals forces. Little energy is required to overcome these forces, so it will generally have a lower melting and boiling point.